Okay, let's see if we can talk about parallel lines cut by a transversal. Okay, these are a set of parallel lines, and this is the transversal that cuts through, which creates 8 different angles. Okay, so they have different angle pair names. Okay, we know what a linear pair is, like 1 and 2 is a linear pair. Vertical angles, 1 and 4, 2 and 3, 5 and 8, 6 and 7. In other words, if you have intersecting lines, vertical angles are the opposite angles, like 1 and 4 and 2 and 3, okay? Alternate exterior angles are going to be, first of all, exterior. And, well, let's go over here. Let's do this. Okay, exterior angles are the angles on the outside of the parallel lines. In other words, 1 and 2, angle 1, angle 2, angle 7, and angle 8, right? Can y'all see that? Yeah, good. Okay, so interior angles are the ones on the inside, right? 3, 4, 5, and 6. So angle 3, angle 4, angle 5, and angle 6. Okay? Now these are the congruent angles. Okay? There's alternate exterior, alternate interior, and corresponding angles. Okay, alternate means on either side of the transversal. You're going to pick from one of these and one of these. Okay? So alternate would be one on one side and one on the other. Okay? Exterior is outside. Okay, so if you're looking at alternate exterior, it'd be 1 and 8. Okay, so angle 1 is congruent to angle 8, and then what would the other two be? Yeah, it'd be the 2 and the 7. They're on either side of the transversal, and they're on the exterior. So those are alternate exterior angles. So you would say angle 2 and angle 7. Okay, alternate interior angles are on either side of the transversal, but on the inside. So you'd have 3 and 6 would be one set of alternate interior, and then 4 and 5 would be one set of alternate interior. So we got 3 and 6, and then angles 4 and angle 5. Okay, corresponding is kind of the weird one. Okay, both of them are going to be on the same side. One of them is going to be exterior, and one of them is going to be interior. So 1 and 5 are corresponding angles. Okay, so angle 1 and angle 5. So it's kind of like, right? So 1 and 5, 3 and 7, 2 and 6, 4 and 8. Does that make sense? It's like I'm just doing this, okay? So we got 1 and 5, 3 and 7, 2 and 6, outside, inside, right? On the same side. Okay, so 2 and 6, and 4 and 8, right? Angle 4 and angle 8. Okay, now the supplementary angle pairs. Before I even go on here, do you notice that all the small angles are the same size? 1 and 4, 5 and 8. They're all small angles, right? All the big angles, the 2 and the 3, and the 6 and the 7, they're the big angles. They're all the same size. And then if you have a small one and a big one, they're supplementary. Okay? As you can tell, that's a linear pair, right? So any small one, or a small one like this one, and this one that is a big one, these two are supplementary. So consecutive interior, I don't like the name. We used to have a better name. We had same side interior before, but consecutive interior will work. Okay, 3 and 5 are consecutive interior angles. Angle 3 and angle 5. They're all on the inside, right? They're both on the inside and on the same side. Consecutive means they're kind of in a row, right? So angle 3 and angle 5, what do you think the other set is? Yeah, of course, 4 and 6. Okay, so angle 4 and angle 6. So all of these up here were congruent, right? And these were supplementary. Like that's a big one and a small one, so they add up to 180. Same over here, okay? Vertical angles, we know those, 1 and 4, 2 and 3. So angle 1, angle 4, angle 2, angle 3, and then down here we got 5 and 8, right? Angle 5 and angle 8, right? And then 6 and 7, so angle 6 and angle 7, okay? Linear pairs, there's a ton of them. 1 and 2, anything on a straight line, 2 and 4, right? 3 and 4, 1 and 3, right? 5 and 6, 6 and 8, 7 and 8, and I don't know if I did 5 and 7, 5 and 7, right? Okay, so those are a bunch of linear pairs. So I'll say angle 1 and angle 2, angle 2 and angle 4, right? 2 and 4. And then angle 3 and angle 4. And then angle 1 and angle 3, right? Angle 1 and angle 3. Okay, down here we've got 5 and 6, angle 5 and angle 6, and then 6 and 8, right? Angle 6 and angle 8. Then 7 and 8, angle 7 and 8 is a linear pair, and 5 and 7, okay? So angle 5 and angle 7 are linear pairs. All right, so you know what the converse is, right? Conditional, you know, you go one way and then the converse goes back the other way, right? So we've got a few things based on the idea of the converse rule, okay? So if these lines right here, M and N, are parallel, if they're parallel, then 1 is going to be congruent to 8. If they're not going to be, right? So that's true. So 1 is congruent to 8. Now I can do the converse and say if 1 is congruent to 8, then M is parallel to N. Why? Because alternate exterior angles are congruent. Okay? So that could be a reason and a proof. So the converse is true. So one lesson that we teach also with this, not just to talk about it being parallel, but trying to know if it's parallel. Okay? If you have, you know, something like this and you don't know if it's parallel, well, guess what? If the alternate exterior angles are congruent, like if I had 100 up here and 100 right here, I could say, oh, these are parallel. Okay? So that's what this idea is. It's like going backwards. We initially talked about all this stuff with them being parallel. Now we're talking about, are they parallel? Well, if this one and this one are congruent, guess what? They got to be parallel. So these lines are parallel. Okay? Same here with alternate interior angles, right? If you had some alternate interior angles that are congruent, like that was 100 and this was 100, then if they're parallel, then 3 is congruent to 6. Okay, I'll just say that's 3 and 6. Okay, and then if 3 and 6 are congruent, then they're parallel, right? Does that make sense? All right. And then, you know, we could write our own. I mean, what haven't I not used? Let me see, I haven't used the corresponding. Okay, so I'll say if M is parallel to N, then angle 1 is congruent to angle 5. Okay, if angle 1 is congruent to angle 5, then it proves that M is parallel to N. So let's say that this one was 80. So this one was 80. If that's true, then these lines are parallel. Okay, why? Because corresponding angles are congruent. Okay, let's go to the back. All right, so this is real easy. Angle 1 is 55, right? So angle 2, well, we know 4 is 55, right? So we could do that. And then we could say that this small one's 55 and this small one's 55. And then, you know, 180 minus 55 would get you 125, right? So that's 125, 125, 125, and 125. Okay, so if these lines are parallel, then these numbers work, okay? So you notice how the alternate exterior are congruent, the alternate interior are congruent, the corresponding are congruent, but the consecutive interior add up to 180. Okay, so 2 is 125, 3 is 125, 4 is 55, 5 is 55, 6 is 125, and 7 is 125, and 8 is 55. Okay? So I'm going to get you to do this, but anyway, you're not here. So this is 112, this would be 68, 68, 112, here and here, and then 68 and 68. You get it, right? Okay, so here we go with this. You can set up equations based on the two ideas. We always talk about whether they're congruent or there's addition, right? Remember the two posters I have on the wall? Okay, so is this addition or is this congruent? Okay, these positions are alternate exterior angle positions. Okay, so they would be congruent, right? So if I wanted to solve this, then I would set them equal to each other, because anything that's congruent, I can set equal to each other. Can y'all see? Yeah. So 7x plus 22. Anyway, so you just solve it. 7x on both sides. You got 3x plus 10 equals 22. Subtract 10 from both sides, and you get 3x is equal to 12, so x is going to be 4, right? Okay, so you plug it back in. So that's 40 plus 10 is 50, right? So shouldn't this be 50 as well? 4, 28, 22, sure, it's 50 as well, okay? All right, this one, are these congruent? Yes, they are. So we would set them equal to each other, right? So we would say 4x minus 36 equals 3x plus 4. And the reason that they're congruent is because they're alternate interior angles. Okay? And since they are parallel, then they're congruent. And we assumed in the beginning, m is parallel to n, okay? So now we solve this, subtract 3x from both sides. It's gone. We've got x minus 36 is equal to 4. And I had to check something. Okay, so I'm going to add 36 to both sides. And so x is equal to 40. Okay? 40 times 4 is 160 minus 36 is 124. And that's 124. Okay? Easy. Okay, and then these two, are they congruent? No, one of them's big and one of them's small, so they must be supplementary, right? So these are consecutive interior angles, okay? And consecutive interior angles are always supplementary. Okay, so this is where you'd use the addition one, right? So you add them up, 5x plus 20 plus 4x plus 25, and set it equal to what? Supplementary, right? 180. Okay, so 5x and 4x is 9x, 20 and 25 is 45. That's equal to 180. Subtract 45 from both sides, and you get 9x is equal to 135. I think that's, what is that, 15? Okay, so x is 15. Let me see, let me make sure. 15 times 9, yeah, that's 15. Anyway, so x is 15. Plug it in here. 5 times 15 is 75, plus 20 is 95, so the other one must be 85, right? Okay. All right, well, it's all yours. Thank you.